So if you don't want to be on tape, don't say anything. Then they're going to sell them for $600 a piece. So find a break-even point. Okay, so first of all, we have to put in a couple equations, right? So what is going to be, the easiest one is revenue. What's going to be the revenue function? Those of you from business, what's revenue?
Profit.
Not profit.
Like the amount
Money?
you make from that selling.
Amount of money you make from selling.
Correct.
So in this case, what's the revenue?
Each unit is 600.
Yeah, so 600 for each unit, so I'm gonna put in 600x. Because you're gonna sell these items, whatever they are, for $600 a piece. Every one you sell, you get 600. Sell 2, you get 1,200. 10, you get 6,000, et cetera, et cetera. What's the cost though? What's the cost gonna be? So we have a cost function. Now, I will tell you, normally they're a lot more complicated than this. This is kind of a basic problem, but what's the cost to the function?
500.
500,000 plus 400x.
So it's 400 of materials for each one, but you had to have $500,000 of setup. So you had to buy a building or build a building or rent a building. You had to build machines, whatever it is. So you got 400 for each item, plus it doesn't matter if you make 1 or 1,000,000, it's going to cost you $500,000 to set up. Okay? Now, you mentioned earlier profit. What is profit?
The money made after everything.
Okay, so give me the equation.
E equals
Want some help?
yeah.
Kevin?
200x.
Okay, technically that's what it is, but give it to me in the form of an equation.
What?
Give it to me in the form of an equation.
Would it be like 600x minus 400x or? Oh.
No,
Oh,
no,
wait.
but give me in the form of formulas rather than numbers.
Formulas?
So how do you calculate profit?
After it's
Oh,
500,000.
I was like, just.
So rather than giving me 600x, you would tell me revenue.
Right.
How much you bring in minus cost. It's revenue minus cost. So you're on the right track saying 200, but it's not quite that because you have that $500,000 deal. So profit equals revenue minus cost. What other restrictions can we put on this? Okay, what does x have to be? What's the domain of x?
Has to be 1 and positive numbers.
Yeah, you want to be positive integers, so x is going to be greater than 0. You want positive numbers. Probably integers because you don't really want to have, you really don't want to have half of a product, right? Half a product's no good. So, okay, so you want the real numbers, x is going to be greater than 0. Okay, what about profit? What's the domain, what type of numbers can profit be?
All real numbers.
Profit, can it be greater than 0? Ideally, right?
Yes.
Can it be less than 0?
Yes.
Yeah.
So, yeah, I didn't mean to put 0 there. That's going to be, hopefully, you can actually put in here infinity. Then it has to be, boy, I'm not having a good day today. Gotta tell you. So P of x, the profit is going to be less than infinity, but it's going to be greater than negative infinity. It can be any number, positive or negative. Okay, it can be any value. What type of value, what type of number is cost going to be?
It's going to be
Greater than
greater than 1.
X is going to be greater than what?
500,000.
No, x is representing the, well, I guess I have x over here, so let me the same for cost. X has to be greater than 0, can be any number positive. Okay, then of course cost is always going to be a positive value, because you've got 500,000, you can't make negative. All right, so we can put some restrictions on it, whatever, but this is our basic concept. And so the question then says, find the break-even point. Okay, so how would you find the break-even point?
Just plug in numbers.
Nope, well, you could do it by brute force, which would take you a while. It's a much faster way to do it. When do you break even? What?
6. Well, never mind, because that's just plugging it in.
Okay, when do you break even?
When the revenue is greater than cost.
Well, so we break even when they're equal. Okay, profits when the revenue is greater. We want to break even, so we would simply do 600x 600x would be equal to 400x plus 500,000. So then you have, here's your 200x that you were talking about earlier, equals 500,000. So x is going to equal what? Divide both sides by 200. X is going to equal 2,500. So that means once you sell $2,500, you've now made up your 500,000 up front. And of course, once again, what are we not computing with this? We're not computing ongoing costs. You know, we're not computing electricity, maintenance on the machines, labor, all those things. Those are all extra stuff as well. That might be included in the 400, we don't know. But kind of a general idea. The idea though is I took these two equations and I set them equal to each other and I solved. And that's what a system is. Okay.
Where'd 600 turn into 200, is that?
Subtracted 400 from both sides.
Oh, subtract.
Just solve your equation. Okay. Okay, so the idea of taking restrictions in form of equations and then making one value that works for both. Okay? All right, so here's the topic then. Lecture 31. And we're talking about systems of equations. And this is one topic you should have had in Algebra 1, you should have had in Algebra 2. I know my Algebra 2 kids, we talked about it. So system of equations. So let's look at definition. Definition is two or more equations, and lack of other wording, very simply, they're solved together. So two or more equations solved together. So it could be 3 equations, it could be 5 equations, it could be 10 equations. Okay? But they're solved at the same time. They have to all be at the same time. Did you just knock on my door? What is knocking on my door? Vincent, was that you? Did you knock on my door?
Yes.
Shame.
I'm sorry, Mr. Phillips.
It's all right. Now, here's the note we have to know about this. Okay? And that is the number of unknowns must be equal to the number of equations. So when I went to linear algebra class and I went to a problem, the problem had 10 variables, had 10 unknowns. In order to get a unique solution, how many equations do I have to have?
10.
I had to have 10. Okay, we're not going to get anything that big, but we're going to talk about 2 and 3 in this section, and then when we get to matrices, we may go up to as many as 5. Okay, matrices is a little bit easier to solve. The number of equations is equal to the number of unknowns. So let me give you an example. If I have an equation like x plus y equals 4, how many solutions do we have to that?
2. 1.
More.
4.
More. What'd you say?
I don't know.
What'd you say?
I don't know.
No,
Infinity?
infinity. There's an infinite number of solutions. Because we know like 2 and 2, we have 3 and 1, we have 1 and 3, we have 4 and 0, we have 0 and 4, we have negative 1 and 5, we have negative 2 and 6, we have 0.1 and 3.9. Okay, we have an infinite number of possibilities, right? But if I give a second equation, if I say x minus y also equals 4, now how many solutions do I have?
2.
Nope.
Four.
Nope. What'd you say?
Still an infinite number.
This one there's not.
What?
I have 2 equations. There's one answer. What is it?
X equals 4, y equals 0.
X equals 4, y equals 0. That's the only one that will make both equations true. Okay, it comes out. So if I have 2 equations, I have 2 unknowns. That will give me one exact answer. Okay? If I have 3 equations, 3 unknowns, I can get one exact answer. All right, so that's what a system is. A system is a series of equations that come up with one particular answer. So let's look at, there's several ways to solve systems. In fact, when you were in Algebra 2, we did elimination, we did substitution. There's numerous ways. The first thing I'm going to ask you to do, though, in class, is I'm going to ask you to verify or I might use the word determine. So I'm gonna give you an equation, I'm gonna give you a system, something like, let's use one of my notes. X plus 2y equals 2. And x minus 2y equals 6. Something like that. And then I'm gonna give you an answer. And I'm gonna say, is 4 comma negative 1 a solution? Question mark. Well, if it is a solution, what does that mean?
That means it has two solutions.
Say it again.
That means it has two solutions.
No. If 4 negative 1 is a solution, what would be true? Yes.
There's at least one solution, or?
You could plug it in and it'd be correct.
Correct. I'm telling you, this is the solution. I'm asking, is this a solution? So if it has to work in both equations, it has to make both equations true. So we simply plug it in. I'm going to go 4 plus 2 times negative 1 equals 2. Is that true or false?
It's true.
Absolutely. 4 and negative 2 equals 2. That is true. What if I put in down here 4 minus, I can't type today. I can't write today. 4 minus 2 times negative 1 equals 6. True or false?
True.
Absolutely true. So the answer is yes. This is a solution to this particular function, or to this particular system. Okay? If it doesn't work in one of them, then it doesn't work. It has to work in both equations. If there's 3 equations, it has to work in all 3 equations. Okay, so the first thing I'm going to do is ask you to verify. It really is as simple as plug and chug. We good with that? Kevin, you good with that? All right, number 2. I'm not so sure why we keep going to our computer. Okay, I'm not sure why we're doing that. So number 2, graphing. Now, this is one thing you did in Algebra 2, you probably did in Algebra 1. I don't like graphing. Why? Can you tell me why graphing isn't necessarily the best?
Because it can go on forever.
No.
If it has like 10 different equations, it takes a long time.
That would be true. Although even with just 2, I don't like it. This is 0 and this is 1 and this is 1. Where they intersect is my answer. What's the answer there? Yeah, right? I mean, it's somewhere between 0 and 1, both the x and the y. Looks like maybe it goes up a half, but it could be 0.4. Could be 0.457. We don't know what it is. So this doesn't give you super exact answers. So when graphing, if we're going to graph it, we're going to use either Desmos. You can actually use the graphers in front of you, the yellow graphers. We can show you how to do those. But let's look at Desmos here real quick, just to give you an example of what they look like. I've got several examples in here. So let's say we have x plus y equals 3. There's my line, right? Okay, what if I give you another one that gives you like x plus y equals 5? What are those 2 lines? We call them
Parallel.
parallel, never going to cross, right? So because they never intersect, how many solutions will I have?
0.
0. No solutions whatsoever. So if they're parallel on your graph, they do not intersect, therefore there's no solution to them. Okay? Let's get rid of that one. What if I give you this one?
Infinite. Infinite.
It's the exact same line, right? Okay? So there's an infinite, everything that works in one works in the other. And you should be able to see that from the 2 functions. Look at x plus y in 3 and 3x plus 3y equals 9. What happened?
One of them is just multiplied by 3.
We just multiplied everything in here by 3. And when you have an equation that might be hidden in there because they may have multiplied by a fraction or something, but you should be able to see some common factor. One of them can be reduced and it looks like the other. So that was kind of one you kind of see. And these 2 are both very uncommon to have infinite and parallel, but they do happen. What we're looking for is one that actually crosses. And then on Desmos, it's very nice because it will tell you right there, tells you what the answer is, -2.5. And even if it's off a little bit, it'll give you a decimal out to so many points. Okay. Now that's with 2 linear equations, and we're going to do a lot with 2 linear equations. However, we're also going to go to parabola. Okay, how many times does a parabola and a line intersect?
2.
I have one here, and I have one on here. And those are not nice numbers. Those are decimal numbers, and we would just round, okay? And then we're also going to get to non-linear, so something like this, where I have a circle
4.
and a parabola, and they intersect at 4 places, okay? So what we're looking for in graphing is we're looking for the intersections, okay? As we get into the graphers on the TI Inspires, I can show you how to do the graphing and find the intersections on those if you don't know how to do that. Okay? All right. So graphing, we're going to use some sort of a tool. I will not have you graph by hand, okay, because I don't like that as a method, okay? Number 3, this is the one that's probably the most important. I think if I only had to pick one method to teach you, I would pick this method, and that's substitution. It is not the easiest, but I think it is the most important because we use it over and over and over and over and over and over. Let's give you another equation, another system. Something like 5x minus 4y equals 9. And the bottom one, x minus 2y equals negative 3. So with substitution, what you're looking for is you're looking for a coefficient of 1. Okay, so what's a coefficient?
Just a XY.
No?
Oh, the number.
The number in front of the variable.
Yeah.
So here I have a coefficient of 5, here's a coefficient of 4. I don't want to use substitution with those. Here I have a coefficient of 1 and negative 2, so I want to use that one right there. Okay? If we don't have a coefficient of 1, then I would suggest let's do elimination, which is number 4. Okay? But if I have a coefficient of 1, then all I'm going to do is I'm going to take this equation and solve for x. I'm going to have x equals negative 3 plus 2y. I'm going to make, so x is by itself. Now, River, why would I want to get x by itself?
Because x is a coefficient of 1.
X has a coefficient of 1, okay, and then what can I do with, now that I have x equals, what can I now do with that?
You can plug it in. Yeah.
I have negative 3 plus 2y, I can replace x. Now, I have to go into the other equation. If I go back into itself, I'm going to get 0 equals 0 every single time. So you have to take that and go back into the other equation. So then in place of x, I would do 5
Oh, yeah.
times negative 3 plus 2y minus 4y equals 9. And now philosophically, or more theoretically, what have I created? I have one equation with how many unknowns? One unknown. I've got one equation with one unknown. Now I'm just solving for y. Okay? I would distribute and then whatever method you want to do to solve, use your algebra skills. We're going to get 10y minus 4y is 6y. Add 15 to both sides. So we end up with y equals 4. All right, so Vincent, am I done?
Yes. No.
No. Why am I not done?
Because you need to do.
Okay.
You need to factor out the y.
Well, I've got y.
Or-
So now I have to go back and find
The x.
the x.
Oh yes, the x. Oh,
'Cause you have to have the
y,
ordered
so,
pair, right?
Yeah, yeah.
Very good. Now, what am I going to do? How am I going to solve for x? Yes.
Plug in y. Put 4 into y.
Put 4 into y. Does it matter where?
No.
It doesn't. I can go into any equation on the board that I want to that has a y and an x in it. Now, there is an easier one. Remember, mathematicians are inherently lazy, right?
Mm-hmm.
So which one's the easiest to go into?
Second one.
No?
Really?
I already have x by itself. I've gone to that one.
Oh.
I already have x by itself. So just plug it into here. X equals negative 3 plus 2 times 4. I mean, if you plug it in anyplace else, then you got to do some extra math and solve. This one, you already have x by itself. So x is going to be equal to 5. So then I have my ordered pair, 5, 4. Now, Vincent, am I done?
Yes, because you have both x and y.
Outstanding. Excellent.
Yes.
And if you want to check it, you can. 25 minus 16 is 9. 5 minus 8 is -3. It does work. So how many times did I actually have to substitute?
2.
Twice. I had to plug x in, then I got my answer and plug it in front of it. All right. Are we good with substitution? Do we need to see it again? You good with that?
Mm-hmm.
What time are we out of here? 10 after?
11:20.
11:20. Thank you for saying that. I would have been done. Okay, so let's do, let's go ahead and jump into my favorite method of solving systems of equations. And that's when there's not a coefficient of 1. In fact, I don't think I ever ask you in homework, okay, in homework might be a little different because we're learning the different types, but on a test or quiz, I never say solve by substitution or solve by elimination. I put on there solve. So I don't care which method you use, okay? But here's number 4, and it's called elimination. Some teachers call it the adding and subtracting method. I just call it the elimination method. Okay? And it really is helpful when we have numbers that aren't, we don't have a coefficient of 1. Because by substituting, you're dealing with some sort of fraction, it gets kind of ugly. So let's do one here. Let's do 3x plus 2y equals, I think it's 49, no, 48. And then we're going to have 9x minus 8y. 9x minus 8y is going to be equal to -24. Now, if we had to try this by substitution, you're going to get some sort of decimal or some sort of fraction. Because if you divide by 3, you're going to get 2/3. Divide by 2, you're going to get 3/2. Divide by 8, you're going to get 9/8. Divide by 9, you're going to get 8/9. Who wants to deal with fractions?
No.
Know what I'm saying? All right, so here's what we're going to do. We're going to look at coefficients. You're going to choose a coefficient. So choose x or y. Which one do you want to pick? I don't care. X. Choose the x. So we're going to pick x. Now, there's numerous ways to do it. I think the fastest way is simply, now pay attention, you're going to switch the coefficients. So what that means is I'm going to take the coefficient down here, which is 9, and I'm going to multiply the top by 9. I'm going to take the 3 of the top one, and I'm going to multiply the bottom equation by 3. So I take those coefficients and I switch them, and I'm going to multiply that whole equation by 9 and by 3. So what does that give us? 3 times 9 gives me 27x. Plus 2 times 9 gives me 18y. It's going to equal 48 times 9 is going to give me 432. Did you double check my multiplication?
Mm-hmm.
Okay. Do the same thing at the bottom. 9 times 3 gives me 27x. Negative 8 times 3 gives me negative 24. And negative 24 times 3 gives me negative 72. And the goal is accomplished by simply switching the coefficients. Now, there's shorter, faster ways to do it, okay? But this is probably the easiest, quick way to do it. Just take the coefficients, switch them. Because what you notice about the x's, you chose the x's. What do you notice about them?
They're the same.
They're exactly the same. And that's the goal. I want to get the coefficients identical, okay? So, if these are the same, I would subtract. What's 27x minus 27x?
0.
0, and I've eliminated the x's. That's what's called elimination. And I've got 0, I've eliminated. So then what's 18y minus a negative 24y? Minus a negative, so
-6.
nope, because it's minus a negative.
Oh.
So 18 minus the negative.
36.
46.
Yeah.
42.
42. 42y. And then 432, careful, minus a negative 72.
That's 504.
540. And then you divide to get your y, divide both sides by 42, and y should be equal to
Something.
Well,
I believe it's 12. So I have y equals 12. Vincent, am I done?
No, you need the x.
I gotta go back and find the x. Now I have a conundrum. Where do I want to go back to plug it in at? Does it matter?
No.
No. I can pick any equation I want. Anything that has an x and a y, I can plug it in. So you guys tell me which one you want to put it into.
The first one.
Oh, okay, thank God. I was hoping you'd say that. So 3x plus 2 times 12 equals 48. Okay. And then you would go through and solve. So 3x plus 24. So 3x equals 24. X is going to be equal to 8. So now I have my answer, 8 comma 12. Yes,
Why do you add the things together?
the equations together?
Yeah.
Well, by adding the equations together, which is perfectly fine to add the equations together, you're eliminating the x. And that's what we want, because if I can eliminate the x, now I have one equation with one unknown I can solve.
No, I was asking like why did you add 24 y to 18y?
You're adding the equations together. You're taking this equation, in this case, we're subtracting this equation. So if everything's lined up, just subtract straight down.
You always
That way you could eliminate the, say again?
Subtracting.
Say again?
So you're subtracting you're using the first equation and using the second, subtracting from the first equation, right?
Yes, now here's the reason why. Because the 27x and the 27x are the same sign, right? They're both positive. So if I added them, what's 27x plus 27x?
54.
54. They don't eliminate. So I want to do whatever operation gets rid of them. So 27 minus
So
27.
if they were negative, you'd add them.
If one was negative, then I would add them. But since they're the same, once again, if it's the same sign, you add. If they're different signs, you subtract them. No,
Other way.
other way around. As soon as I said different, you subtract, I was like, I think I just said that wrong. Same sign you subtract, different signs you add, because it's same sign subtract. Same subtract.
same side and keeps.
Yeah. Different sign add. Yeah. How many of you remember elimination?
Kinda, yeah.
Kinda? Remember it all? V, you remember this?
It's algebra 2.
It's actually algebra 1, but we did it again in algebra 2. Okay. Okay. Let's have you try one on your own. I don't think I want to get into 3 equations today. I don't think we have time for that. But let's have you try one on your own. Try 4x plus 5y equals 3. In fact, if someone would like to come to the board and try it, that would be awesome. 4x plus 5y equals 3. 2x minus 3y equals 7. You daring us to try on the board?
Yeah.
Do it nice and neat so we can read it. I don't have the answer to this one, so you better get it right. Remember what to do?
Wait, which one are we doing?
4x plus 5y equals 3.
Does it matter the type?
I would use it, because I just did elimination, I would use elimination. Partly because there's no coefficient of 1. River, you okay being on video?
Yeah. 7 times 4.
28. So you know what you're doing, you got the answer. That's what you got. That's what you got. Vincent, is he done?
Yes, yes.
Is it correct?
Yeah. I'm not sure.
You said yeah? Is that what you got, or did you check it?
I did the same thing.
You did the same thing? Did anyone check it?
I checked it.
Okay, you checked it in your head? Okay, so yeah, absolutely, 4 times 2 is 8, whoops. 4 times 2 is 8, plus 5 times -1 is -5, that absolutely equals 3. 2 times 2 is 4, -3 times -1 is +3, that absolutely equals 7. It checks them both, okay? So really, there's no reason not to get the right answer, because you can always go back and check. Just don't make computation errors, okay? All right, that's elimination, okay? All right, so, in short, if I have 2 linear equations, how many possible solutions can I have? 2? Can I have 2?
Yeah.
No?
Oh.
Draw me 2 lines that intersect twice.
Oh. 1
I can have 1 solution,
or 0.
or 0, they don't,
Or
they're
infinity.
parallel, or
infinity.
infinite number of solutions when it's the exact same one, okay? And it doesn't matter if they're perpendicular, as long as they intersect, you could have 1 answer, and this is the one we want. That goes as an actual solution, okay? All right, when we come back on Monday, we are gonna look at some applications and potentially 3 equations and 3 unknowns. And then when I come back from Florida, we're gonna look at nonlinear problems, and then get into matrix.